Good morning and welcome to my presentation. The topic that is effect of graded levels of nitrogen applications on quality of multi-cut fodder sorghum genotypes, that is COFS 29 and COFS 1. Coming to the introduction, that is India has having the largest livestock populations of 536 million heads, which is about 15% of the world's livestock population. And India supports up to 55% of the buffalo populations and 16% of the cattle, 20% of the goats and 4% of the sheep population. Uh, However, the country has only 5.23% of the cultivated area under fodder crops, with an annual total forage productions of 1058 million ton. That is 590 million tons of green fodder and 467 million tons of dry. Whereas the annual forage requirement is 1594 million ton. Because 1025 million tons green and 569 million tons of dry fodder, that is requirement. That percent of amount of fodder should be produced by the our farm community. The present feed and fodder resource of the country that can meet up to only 42% of the requirement, with vast deficit of 61% of the green and 18% of the dry fodder. So coming to the multi-cut fodder sorghum, the sorghum, it is a drought-resistant fodder crop belonging to the family Gramineaceae and Poaceae. So sorghum, it is commonly used for the basic feed for the livestock, and there was a long felt need for the multi-cut fodder sorghum with about 5 cuts in a year to save on the seed cost and conditions to supply the green forage to dairy animals throughout the year. To fulfill this demand, a multi-cut fodder sorghum COFS 29 and COFS 31 were developed from the TNU, that is Tamil Nadu Agriculture University in Coimbatore, and released it is in 2001 and 2014 respectively. And COFS 29 was introduced in Karnataka, particularly at US Dharwad, that is in 2007 and 2008. So coming to the physical and chemical properties of soil, that experimental site, it has the physical property of, it has the clayey soil texture, but chemical properties has the alkaline in pH and normal EC and medium organic carbon content, that is 0.51, and the medium nitrogen level, that is 289 kg per hectare, and medium phosphorus, that is 35.6 kg per hectare, with high potash, that is 460.5 kg. So coming to the experimental detail, the crop that is multi-cut fodder varieties COFS 29, COFS 31 were used. The location is KVK from Vijayapura. Split plot design with 3 replications and 10 treatment combinations. Season, that is 2019 and 20 in Kharif season. Gross plot 5.4 meter to 5 meter. Net plot, that is 3.6 meter to 4.2 meter. Spacing, that is 45 into 10 centimeter. 10 ton per hectare FIM were used in 3 weeks prior to the sowing of the crop. RDF, that is 175 40 kg of NPK. So treatment details, varieties COFS 29, COFS 31 were used. In nitrogen levels, that is N1 100 kg, N2 125 kg, N3 150 kg, N4 175 kg, N5 200 kg nitrogen per hectare. Recommended dose of phosphorus and potassium was applied to all the treatments at the time of sowing, while nitrogen was applied as per the treatment. That is, the nitrogen at all the levels is divided into 6 equal parts at that is sowing, 30 days after sowing, and after each cuttings for 4. So this is the quality parameters given by the Tamil Nadu Agriculture University about COPS 29, COPS 31. Here we can observe that COPS 31 has the higher quality parameters with respect to the dry matter yield, crude protein and crude protein yield, but it has the lower crude fiber content, that is 19.8%. So crude protein content of the multi-cut fodder sorghum genotypes as influenced by the varied nitrogen levels. Here we can observe that among the two varieties, the COFS 31 shows the significantly higher crude protein content. With respect to nitrogen levels, among the 200 kg application of nitrogen has shows the significantly higher crude protein content. With respect to the interactions, P2N5, that is COFS 31 with 200 kg nitrogen application shows the higher crude protein content, but it has no significant difference in treatment. combinations. Coming to the crude protein yield of multi-cut fodder sorghum genotypes as influenced by the varied levels of nitrogen. With respect to variety, the COFS 31 has shows the significantly higher crude protein yield, and with respect to nitrogen levels, as the nitrogen level goes on increases, the crude protein yield also goes on increases. Whereas in treatment combinations, V2N5, that is COFS 31, and application of 200 kg nitrogen shows the a significantly higher crude protein yield in first, third, and fifth cuttings, and also it has shows significantly higher crude protein yield in the mean. Coming to the crude fiber content of multi-cut fodder sorghum genotypes as influenced by the varied levels of nitrogen. Among two varieties, the COFS 29 has shows the higher crude fiber content compared to the COFS 31. So COFS 31 has lesser the crude fiber content, means it has the good quality of that fodder. And nitrogen levels, as the nitrogen level goes on increases, that crude fiber content also goes on decreases. And coming to the treatment combinations, with the V1N1, that is the COFS 29 with the 100 kg of application of nitrogen shows the higher crude fiber content, but the treatment combinations are non-significant. Coming to the crude fiber yield of multi-cut fodder sorghum genotypes as influenced by the varied levels of nitrogen. Among two varieties, the COFS 29 has shows the higher crude fiber yield, but there is no significant difference between the two varieties. And with respect to the nitrogen levels, as the nitrogen levels goes on increases, application goes on increases, the crude fiber yield also goes on increases because of the higher yield, that is higher dry matter content. And the with respect to the treatment combination in interactions, P2N5 shows the higher crude fiber yield, but there is did not shows the any significant difference between the treatments. This is the some supporting literatures. The Pereira and his co-author observed that with increasing nitrogen applications from 0 to 135 kg per hectare, there was a significant increase in the crude protein content. Increasing nitrogen rates from 0 to 150 kg per hectare significantly increased the crude protein content. Application of 150 kg nitrogen per hectare increased the crude fiber content. Similarly, the results were obtained by Mutina Lucio and his co-author. Coming to green fodder yield of multi-cut fodder sorghum genotypes as influenced by varied levels of nitrogen. Here the COFS 31 shows the significantly higher green fodder yield. As the nitrogen level goes on increases, the green fodder yield also goes on increases. With respect to the treatment combinations, the V2N5 shows a significantly higher green fodder yield, which is also on par with the V2N4, that is COFS 31 with 175 kg nitrogen. So coming to the dry fodder, that is dry matter yield of multi-cut fodder sorghum, here the COFS 31 shows the significantly higher dry matter yield, and as the nitrogen level goes on increases, the dry fodder yield, that is dry matter yield, also goes on increases. Within treatment combinations, the COFS 31 with 200 kg nitrogen application shows a significantly higher dry matter yield, which is also on par with the V2N4. Coming to the supporting literature, Patan and his co-author reported that in multi-cut oat, with increasing the nitrogen levels from 0 to 120 kg nitrogen per hectare, there was a significant improvement in the green forage and dry matter yield. The application of 120 kg nitrogen per hectare recorded a significantly higher green forage and dry matter yield than all other levels of nitrogen. Coming to the conclusion, COFS 31 recorded a significantly higher green fodder yield, dry matter yield, and also enhanced the fodder quality than COFS 29 with respect to crude protein, crude fiber content, and crude fiber yield. Among the varied nitrogen levels, applications of a 200 kg nitrogen per acre recorded the higher green fodder yield, dry matter yield, and enhanced the quality as compared to the other nitrogen levels of application. However, it is on par with the application of 175 kg nitrogen per hectare. Among different treatment combinations, COFS 31 supplied with 200 kg nitrogen per hectare recorded the higher crude protein content, crude protein yield, crude fiber yield, green fodder yield, and dry matter yield over other treatment combinations. However, it was on par with COFS 31 supplied with 175 kg nitrogen. So this is the general view of the photographs, and this is V2N, and this is V2N4 COFS 31 with 170 kg, COFS 29 with 200 kg, COFS 29 variety with 100 kg, and this is general harvest. Thank you.